So there's our bell work. Hopefully you guys have the blue sheet by now. And there's our answer. So A, P, and P was proportional. And then if you simplified that, even with a calculator, you should get that answer. But the calculators won't do the absolute values. And then simplifying those mixed numbers, just multiplication. And yeah, the calculator will do that for you as well. So our objective today, I can write expressions with symbols. And we should be able to evaluate them as well. But we'll see how far we get. All right, before we get started on this, this unit's pretty crucial. Like if you guys are struggling in this unit, of course that doesn't mean you can't advance, of course, but it does mean that the stuff that we're going to be doing in the future is going to be super difficult. So make sure you pay attention in this unit because you're going to be using these skills, maybe not even in the same way, but in similar ways throughout 8th grade and 9th grade and so forth. So as you look around your classroom, you may see many things that can be counted or measured to increase the efficiency of the custodial crew. The head custodian, Mr. Parks, decided to think about all the components that affect the way the classroom runs, make it easy to assign the symbols for each counter measurement that he wanted to consider and made the following table. So he's formulated some symbols here, and then of course he's also shown what they mean so that we can understand without having to write full sentences, but using math sentences symbolically, we can actually write these sentences out in what would be considered much shorter hand on this, okay? This first one, it says, write an expression for the total number of desks in a room. All right, so since we're going to write this for a total desks in a room, let's look at some of the symbols that were given to us, right? Like D, and these are subletters on the side of those. So it'd say like D sub S, that's that first one. It says it's the number of student desks in a classroom. And then, it says C sub D is the cost of each student desk. D sub T is the number of teacher desks in the classroom. And R is the number of student desks. And then the other ones I don't really see have anything to do with desks. So the ones that we're looking here at are D sub S, the number of student desks in the classroom, and also D sub T, which is the number of teacher desks in the classroom. So if our custodian said, hey, I want to know what the total number of desks are in the classroom, of course, you'd have to figure out how many student desks there are, and also how many teacher desks there are, and add those two together. All right. Now, we keep these using symbols like this because not all classrooms have the same number of teacher or student desks. So it varies, okay? And that's why these symbols like this, we also call them variables because they vary in value. Now, if you're thinking that you could have switched those and said, well, what if I wanted to write instead D sub T plus D sub S, right? That'd be teacher desks plus student desks. And hopefully we understand that's just the commutative property of addition. So yes, that would be perfectly fine in that case. And number 2, write an expression for the total cost to replace all of the lights in the classroom. You guys take a look at this. We want the total cost to replace all the lights in the classroom. Just see if you can write this expression. We'll give you 1 minute though. 1 minute, go. All right, hopefully you guys have that. Let's look. So again, you have to read through some of these and figure out which ones you actually need, right? Now we're looking at the cost to replace all the lights in the classroom. So you got the cost of each light bulb, C sub L. So we'll write that in there, C sub L right there. And then that's the cost of each light. But how many lights are in the classroom? Well, that shows right here the number of lights, which is just L. And that's a full capital L on that. Well, you got the cost of each light, and then the number of lights. So hopefully we remember that would be multiplication. It's telling us how many groups of something that we have. The groups would be L, and then the something would be the C sub L. And again, because the number of lights in each classroom is different, we keep this expression written this way so that our custodian could just replace these with values as he looks at each classroom. Yeah, so this one, you could say, well, you're going to take the number of lights and multiply it by the cost of each light. And yeah, these are the same. And this again, this goes back to the commutative property of multiplication for this one. So these are the same, and it doesn't matter which order you put them in. All right, well, let's write an expression for the cost of replacing 3 student desks in the classroom. Okay, so this is the cost again. So again, we got to look at this table, and right here it shows it's C sub D. That's the cost of each student desk. Now we got 3 of these though, right? So there's a couple ways to write this out, especially since we're only 13. I'm sorry, 13 desks. I only saw the 3. Well, that's different actually, because you could write C sub D like this and just add it to itself 13 times, right? But it would be easier to say, well, you got this 13 desk, you got 13 groups of it. Now, I'm showing the multiplication between that, but it's not required that you do. So 13 groups of the cost of 1 student desk would tell you how much 13 student desks would cost. All right, what about an expression for the number of student desks per row? All right, so student desks per row, there's a couple that give us desks, right? We got the number of student desks in the classroom, and then there's something about desks in a row. There it is, just R right there, right? Number of rows of student desks. Well, if you take the total number of desks in the classroom and divide it by the total number of rows, that would tell you how many desks would be in each row. Now you guys look at this classroom and you see that not all the rows have the same number of desks, but this would give you a nice average, I guess. So that's what we're going to do. Take the number of desks in the classroom and divide it, and you know there's a couple different ways to show the division on this, by the number of rows. You can do it like this. I actually prefer to do it in a fraction form, just like we talked about with rates. Because this would tell you the number of desks per 1 row, which is a unit rate. And so the fractions make that pretty convenient. Write an expression for how many more light bulbs there are than teacher desks. All right, this is a good one. You guys take a minute and try this one out too, okay? 1 minute, go. All right, hopefully you guys got that down. So the 2 things we're comparing on this one is light bulbs. So that'd be light bulbs in the classroom. That's just L right there. And we're comparing this with the number of teacher desks in the classroom, I guess, which is D sub T right there. Now, since it's asking how many more light bulbs there are than teacher desks, this would end up being a subtraction problem. It's light bulbs minus the teacher desks, like this. And yeah, the order does make a difference on this one. And you may ask, well, what if there are less light bulbs than teacher desks? Well, it just means you end up with a negative value, which can be quantified if you actually wrote that as a sentence. You just say that there's more teacher desks than light bulbs, however many came out of that, okay? So I suppose if you wanted to, perhaps absolute value would be called for. It would just need to be specified, whatever the answer is, positive or negative. Well, let's write an expression to represent the cost of 7 pens. Okay, well, we got some pens down here. There it is. I got the cost of each pen. So that's also the cost of 1 pen, right? Cost of 1 pen right there. But this one wants 7 pens. Well, you take the cost of 1 pen and multiply it by 7, and yeah, you'd have the cost of 7 pens. And once again, you don't have to show that multiplication right there. So whenever you guys see that the operation is not shown between 2 values, whenever you see that, even if it's between letters, just remember it is multiplication, okay? Because we're going to be seeing some of that stuff. So the sub letters here are just to differentiate between other similar letters. Like we got the capital C, but then this one has that sub P business right there with the pens. But it allows us to use C's in other places like here and here with different sub letters just to show that it's looking at the cost of other things. So C is really cost, and then the subletter tells us what it's the cost of. So you're right, if you said, well, the cost of each pen was $3, you would replace all of it, not just the C, but also the P. It would just be 1, 3 right there. Okay. So that you wouldn't have the sub part on that number either. So it'd just be 7 times 3, which would be $21. You know, if each was $3. So I talked about variables here. Variables are just unknown values. They're usually represented by the letter X, but you can use other letters, just like we saw with those variables that we were just using, right? Like C sub P or L or D sub T, whatever, okay? We just generally avoid the letters O, I, L, and E. So I, you guys are going to learn about imaginary numbers later, which is slightly important. Lowercase l's, right, they just kind of look like ones, so we kind of avoid those. And then E is Euler's constant, which actually has value by itself. So we don't usually use E. And then capital O, even lowercase o's, sometimes they look like zeros, so we don't use those, okay? Sometimes they represent many values, though, which we're going to get into, but just not really in this unit. So for now, when you see these variables, the letters, they're going to represent numbers, but only one number for now, okay? And using and defining variables is a key feature in problem solving and just mathematics, generally speaking. But just like we saw with like the cost of the lights, right? It was I think C sub L times L or something like that. Right? It allows someone to go in and say, well, I know the formula for finding the cost of the lights, and then we would replace, like, let's say that there were 10 lights. Well, I mean, we got 9 in here, but let's say there was 10, and then the cost of each light, I don't know, $5. Maybe it should be 50. I don't know. Whatever the case, right? And then you'd say, well, for this classroom, there would be $50 to replace all the lights, that kind of thing, okay? So just remember, the letters actually represent numbers, but the numbers may differ depending on the scenario, or in this case, the classroom that you're in, right? So that's why we got to learn how to evaluate these. Now, later on in this unit, this would be the last step that you'll be doing, okay? This is how you actually check your work to make sure you've done it accurately. But remember, these problems will show a value for a letter. You just replace the letter with whatever number they give you, and then you evaluate or simplify it into one individual number, which means that you could also just plug it into the calculator, which is a pretty handy tool. It's like this one. We got two different expressions. It just wants us to replace x as 5. But these are two different problems, really, that are combined into one. So let's look at this first one right here, right? It said that x is 5. So right now, we got the expression 2 times x, that's an exponent of 2, minus 14. But it says, you know what? X is 5. Okay, we'll replace x with 5. Now, I'm putting this in parentheses so that it doesn't look like 25, okay? Now, you could have just put multiplication between it. But I like to use parentheses because once we start seeing negative values, the parentheses are going to be crucial. All right, now just by the order of operations, not that you'd have to because you can use a calculator for this, because you guys know you could type this in directly, even with the parentheses, like just above the 8 and 9 on the calculators is the parenthesis buttons, okay? So you could type this in exactly like you see it, but because I'm a math nerd, I'm going to actually do the work. So the order of operations would be 5 to the power of 2, which is 5 times 5. And that would give you 25 out of that exponent, right? Well, now I got 2 times 25 minus 14. And then 2 times 25 is 50. And then still minus 14, right? Just order of operations. And 50 minus 14, boom, 36. And your calculator should have given you the same answer. Okay. Now, again, this is what the answer you would get at the end, right? This is how you check your work, which is why this skill is so crucial, because knowing that you need to replace the letters with numbers is how you make sure that your answers are actually correct and that you've done the math correct. Yeah, we got this one as well, right? Now the order of operations, I mean, I guess 3 operations on this one just because of the parentheses. Well, let's rewrite it, okay? It was x minus 3 all to the power of 3, but again, we said x is 5. So let us replace x with, 5, right there. And you can put double parentheses on the calculator. You can again just type it in exactly like you see it, which is what I do recommend. It'll save you some time and some stress. Just if you type it in incorrect, then sometimes that causes problems as well. So on the calculator, if you look just to the left of 7 and then up 1 button, you're going to see this button right here. It's a caret symbol. Then you like this one, you type the 3 in after you push that button. So that's the exponent button on the calculator. Well, let's evaluate this just because it's good practice, I think, right? So we could say, you know, let's go ahead and do the subtraction here. 5 minus 3 is 2. And then it's really just 2 to the power of 3, which is just 2 times 2 times 2, which is 8. Bam, we did it. All right, so there's the work on those two. And again, it's just, we need to understand that it is possible to replace letters with those numbers and then evaluate from there, which, you know, you should have acquired some of those skills in elementary at least. So anything divided by 0, by the way, like you're saying 8 divided by 0, right? Well, think about what division is. It's saying how many zeros are in 8, right? So it's 0 divided by 8.
0.
Let me make sure I got that right. How many, I have that backwards. That's why I'm thinking of that wrong right there. It's actually 8 divided by 0. So how many zeros are in this 8? Now, you could say 0, but that's actually not true. Well, you know, how much value is in 0? There's no value, actually. Which means that you could say that it goes on for infinity, actually. Which is why we say it's undefined. Well, that's not a U, but not an I, but a U. Undefined. Okay, so when you see anything divided by 0, it's undefined because 0 has no value, so you can multiply it by any number as big as you want, and it still wouldn't actually reach the value 8, which is why we say it's undefined. And that's also why the calculator is saying that you have a divide by 0 area. You're not supposed to divide by 0. It's saying the number's so big, I'm going crazy over here. All right, here's another one. Now this one has 2 different values to replace. But go ahead and see if you guys can do this one. And yeah, again, I'm still recommending you do it on the calculator. Let's see if you guys can do this one. 1 minute go. All right. Hopefully you guys had enough time to do that one. If you got the answer is 12, this means you typed it in wrong. Okay. So again, this goes along with a little bit of practice on this. So right here it says that x is 7. Right. So I replace x there with 7. And the y is negative 2, and I replace it with negative 2. Now, again, notice I'm putting that negative 2 in parentheses. So our new expression looks something like this, minus, I should have given myself more space, but something like this, okay? And but just by the order of operations, right? You'd say, well, 7 minus 5, there's a 2 to the power of 3, so that one's going to be 8 right there. And right there, that's negative 2 times negative 2. I'll show the word for that, which is why this ends up being a positive 4. And if you did not use parentheses, the calculator thought you didn't want 2 negatives, you wanted 1 instead. So now I got negative 2 times 8 minus 7 times 4. That's a times right there. Negative 2 times 8 is negative 16 minus 28. And you should have gotten a negative 44 on that. All right, so again, if you got a positive 12 on that, it means that you didn't use parentheses right here. But we do need those parentheses. We need those parentheses very badly. Typing that into the calculator. And that has to do with the exponent, because the calculator, again, it has to do with its computer programming, which is also at least kind of mathematical. So yeah, make sure you're using those parentheses, especially for negatives. Especially for negatives. About the parenthesis thing, right? So we'd say, let's look at a couple examples like this one. We'll say negative 2. Well, I'm going to use different power, though. Now, if you were to expand this, and this is the important part because this is the way the computer looks at it, in addition to the way that we look at it mathematically speaking. So this is 2 to the power of 4, right? Because you got to do the exponent first. It's 2 to the power of 4, 2 times 2 times 2 times 2, and then you'd multiply it by the negative. So that's one negative, which is going to make that, in this case, negative 16, right there. But with the parentheses like this, again, it's still order of operations, but it's negative 2 in parentheses 4 times. So you'd have 4 sets of parentheses, and then you say, well, what's inside the parentheses? Negative 2. like this, which is in turn shows 4 negatives being multiplied. 4 is even, so it's a positive answer, and 2 times 2 times 2 times 2 is 16. Now, I mean, if that was a 2 in the parentheses, of course that doesn't really matter, but since it's negative, that's the crucial part, and that's why we have to use the parentheses with those negatives when it comes to the calculator, and exponents at least. So let's do this one together so you guys can get started on the assignment, right? So this is what it shows: x to the power of 2 plus 6x plus 8, like this, and then x minus 2 in the denominator. But over here it's saying that x is negative 2, so I'm replacing x with negative 2, just like it tells us to do right here, right? And again, right here, I'm not just going to write negative 2 with that exponent. I need the parentheses right there, okay? And then it was 6 times x, which is, x is negative 2. And then here on the bottom, x minus 2, so negative 2 minus 2 right there. All right, now, when you guys type this into the calculator, the first button I would push is that n over d button, because it's going to give you the fraction right away. That's 3 buttons above 7. I know we've used it, but just as a quick reminder. And yeah, that allows you to type this in even with the parenthesis buttons, which again are above the numbers 8 and 9 on the calculator right there. And let's see, I'll type this into my calculator too so we can practice using, right? Parenthesis, negative 2, close parenthesis, to the power of 2, plus 6 parentheses, negative 2, close parentheses, plus 8. Now if I use the cursor button to go down on this, I can get to the denominator, parenthesis, negative 2, close parentheses, minus 2, and I've got it all typed in, so I just need to push enter, and this actually gave me 0 on that one. Thank you, calculator. That was nice. So if you had worked this out, you would have gotten 0 over negative 4. Now, this one's different than what we talked about earlier. This is 0 divided by negative 4, like this, right? Well, how many negative 4s are in 0? None. And we can even check that, right? Just going back to what we learned with like checking this kind of long division. Right, what's 0 times negative 4? It's 0. All right, so there's our objective again. I can write expressions with symbols and also evaluate expressions.